Okay, so we're here in the iBook now, and I really like these iBook problems because it kind of summarizes everything we talked about in today's videos and yesterday's video. Side, side, side. Remember, we got side, 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 which we talked about today. We got angle, angle, and we got side, angle, side. Why do I bring that up? If we look at question 1, which of the following is not a way to prove two triangles are similar? Well, we don't have an angle side angle. It's that one. All right, that's a congruence postulate, but we're talking about similarity, so that's the answer to number 1. Number 2, all right, are these two triangles similar? Yes, they are. All right, we have A and D, and then the angles in the middle are vertical angles. You have to be able to identify vertical angles in the middle. Can't zoom in on this picture, but just believe me. All right, angle, angle, boom, that's it right there. Hopefully ACD and angles DCF, those are the vertical angles. All right, number 3, all right, are these two triangles similar? All right, well, notice how, let's look at EF, side EF over side BC. That's 20 over 10. That reduces to 2. All right, that's that scale factor. All right, so that means that basically every side length has to be doubled. But quickly looking at DE over AB, we got 25 over 15. That's not 2. All right, so these aren't similar. All right, that's unfortunate. I was really hoping that they would be. I feel a little let down. Okay, are these similar? All right, so first off, notice that these don't necessarily have to be reflected. These triangles are typically rotated when they look like this, not all the time, so I should write not similar for number 3. And make sure you're writing this stuff down, because I will look at it, and if you don't have anything written down, you will not get the points. All right. Now, AB over BD is going to be 27 over 18, which is 3 over 2. EB over BC is going to be 36 over 24, which again reduces 3 over 2. And then angle B, we got angle ABE and angle CBD in the middle. We got vertical angles in the as an included angle. So they're going to be congruent, or excuse me, they're going to be similar by side, angle, side. All right, two sides are proportional, and we got an included angle that's congruent. Nice. All right, are these similar? And the answer is going to be yes. All right, we have parallel lines cut by a transversal. Let me just draw this picture really fast. All right, I'm not going to spend too much time making it look super pretty. You can if you want. I'm not. All right. Now, parallel lines cut by a transversal. Most of the time, we're talking about alternate interior angles. I say most of the time, not every time. We got parallel lines, DE and AC. That's what those arrows mean. Notice that we have corresponding angles right here. All right, we got corresponding angles there, and then similarly going on over here, these would be corresponding angles. So we got corresponding angles over there. So these two triangles are going to be similar by angle, angle. Check answer. Good. All right. Are these triangles similar? All right, I'm gonna say, my guess is gonna be yes, but I'm not sure. I'm really not sure. So let's do some math. All right, let's just start doing, like, matching up numbers. 28's the biggest on the triangle on the left. 20's the biggest on the right. Let's see, that's gonna, what goes into both of those? 4 goes into both of those, so that's gonna be 7 over 5. All right, what's the next biggest numbers? 21 and 15. Those are the middle numbers. A 3 can be factored out of both of those, 7 over 5. And then we got the smallest numbers, where only 2 can be factored out of those, 7 over 5. So all side lengths are proportional, so the triangles will be similar by side, side, side. All right, nice. All right, let's do number 7 now. All right. So, number 7, angle B is included angle. Angle E, notice how it's not between, it's not included. All right, so we can't use side angle side. It doesn't matter if you have a congruent angle and 2 sides that are proportional, we're not allowed to use it. All right, so I can already say I'm going to say we need more information, or let's just say these triangles aren't similar. All right, I guess the sides aren't proportional, I didn't really check, but not similar at all. All right, we're just going to go with not similar on that one. All right, so and these questions are really good too. All right, they make you think. I'd say these are probably like, a lot of these are kind of tier 2 questions. All right, we have triangle BED, and we can say, is it similar to triangle BCA? All right, clearly angle E is 59 degrees and angle C is 59 degrees. All right, so I know angle E is congruent to angle C. All right, they have the same measure. Next, I have an angle B and an angle B. Angle B is congruent to angle B in both of them. All right, they share angle B, angles congruent to itself by reflexive property. So these are going to be similar by AA. All right, they both have they have 2 pairs of congruent angles. And then the side effect of that is angle D and angle A would be congruent as well. All right, which of the following is false? All right. So number 9. All right. Let's see. Let's just go down. BD. What's the length of BD? Is 21. BA is 21 plus 7 or 28. BE is 24. BC is 32. 24 plus 8. AC is 36. And looks like we got to calculate AC really fast. Let me think. They didn't tell us AC, but anyways, notice that this is going to reduce to 21 over 28 reduces to 3 over 4. That's going to reduce to 3 over 4. All right, we'll just pretend. Let me think about how I want to say this. We're going to just say, well, that's 48. Hold on. Time out. This last one's a little bit goofy. I should have wrote it like this. I should have said DE. Hopefully I didn't confuse anyone. Over 36. So DE, that's going to ultimately end up being 27. We'll just accept that as fact as 3 over 4. Alright, they are similar. All of these are proportional. The scale factor of perimeter, though, is not 3. Alright. Why? Notice how the scale factor is 3 over 4. Alright? Scale factor is 3 over 4. It's not 3. It's saying which one's false? What? These are all false statements? I think this problem has a typo. Oh, actually, hold on. I see what happened. I got bamboozled by this problem. I didn't read it clearly enough. All right, this one has a messed up proportion. All right, I got bamboozled when I wrote this. This was my mistake. This should have been AC over DE, and that's how I wrote it initially, when it should have been DE over AC. All right, look at me. A smart guy even got tricked by this problem. All right, writing the similarity statement, B D E should have been B A C. All right, that's not how it's written. The scale factor is not 3. They're all false. So I was saying some true stuff, but I got tricked by this problem. Look at me. I'm so embarrassed, kind of. All right. What's the value of EB that would make these similar? Well, notice how, let's just focus on this left-hand side. We have 21 compared to 7. And then we have 18 compared to EB. All right. Again, sometimes you can simplify. You can say, well, this simplifies to 3. And when you cross multiply, you're going to get 18 equals 3 EB. Divide both sides by 3. EB equals 6. Hopefully I did this problem right. I'm still flustered by me jacking up that last problem. I'm so sorry. Maybe you guys can find it in your hearts to forgive me. If not, I understand. That's how you do that problem right there. So it's a lot of times just make sure you match up your corresponding parts up the proportions. That's crucial. All right. All right. One triangle has side lengths of 6, 8, and 10. A similar triangle has perimeter of 60. All right, so let's just find the perimeter of the 6 plus 8 plus 10, and that's going to be 24. That's the perimeter of the little one. The perimeter of the big one is 60. All right, so it's saying if the perimeter of the little one equals the perimeter of the big one, or over the perimeter of the little one over the perimeter of the big one, and then we have a side length of the little one over the side length of the big one. Remember, those proportions are the same. So really you can say I have 24 over 60. The littlest side is 6. What's the corresponding side length for the other one? And I'll just call that X now instead of S sub B. All right, you can simplify beforehand. I'm going to just bash this all into a calculator and see what X will equal. What's 360 divided by 24? 15. And then last problem. All right. So this is kind of the same concept. This is kind of a good general overview of everything we've talked about so far. So one triangle, the perimeter or the side lengths is 7, 8, and 14. So you add those all together, you get 29. All right. Remember, the perimeter of the little one over the perimeter of the big one, that's the same as the scale factor of side lengths. So really, the scale factor, I can also write it like this: the scale factor of perimeters equals the scale factor of side lengths. So if I have 29 over 87, well, what is that going to be? Well, that's 1/3. Or I could write it like, oop, that should have said 87. 87 over 29 is 3. It's none of these numbers. All right. So that's how you do that. Hopefully you enjoyed these notes. And tomorrow is a quiz. Good luck.